Hello, my name is Rich Howard, owner of Architectural Builder Supply. In this video is to bring you a closer look at the Bommer number 7122-600. This is a spring pivot that is a double-acting spring pivot. And this model of spring pivot you will often see in, quite frankly, you're going to see these in courtroom doors. This sort of, had it upside down. This sort of item is pretty often seen in that sort of application. A cafe-style door, one in which you really require the ability to adjust the tension, and you need the ability to have something operate at a very high volume or frequency of use, is where you're going to use this rather than a typical gravity-style pivot, or where you would very typically just simply see double-acting spring hinges. Something like this will be considered substantially more robust and capable of very long-term sorts of installations. I've seen these installed in doors that were very old, in fact, and they work very well, is why people use them. So the 7122 series from Bommer, in a nutshell, is going to be a steel-based item rather than brass. They make these out of brass as well. That is double-acting. So this is a double-acting spring hinge, spring mechanism. The balance of the unit is the top pivot as seen here. This is the door portion of the pivot. Okay, so that will be your top portion. And of course, here's your bottom portion. The 7122, again, double-acting, adjustable spring tension, has a maximum door width of 36 inch with a maximum thickness of 2.5 inch and a maximum door weight of 75 pounds. And a series of double-acting units are available in adjustable and non-adjustable tension. The non-adjustable version of the steel double-acting pivot is the 7022. The same unit is available in a brass material in a adjustable spring tension, which would be the 7322, and the I do not believe they offer it non-adjustable in brass. No, they don't. So 7022 is non-adjustable steel, 7122 is adjustable steel, and then they offer a 7322 brass adjustable. So why would you want brass? Well, you're going to get a very different finish on solid brass than you would on a steel-based product. And that's, really where you're going to end up seeing that, because you're looking for an architectural finish. And what I'm driving at with that is the, polished brass is going to give a different look when you are polishing solid brass rather than plating steel. That would be an example of why you might want that. So the item that we're specifically dealing with, our 7122 pivot, is steel-based and double-acting, adjustable spring tension, and non-handed. Maximum door size, we've given that 36 inch wide, 2.5 inch thick, up to 75 pounds. Fits doors not less than 1 inch thick, however, because the bottom arm needs to sit on the door or sit under the door. Anything smaller than 1 inch, it's found not to be really compatible with. Flat jam bracket, fits jams not less than 1.25 inches wide. That's going to be a reference to the jam bracket here for the top pivot, and then of course the jam bracket for the bottom double-acting portion. The top pivot with jam bracket we've talked about, and then fasteners are included. Now there are several supporting documents that are down below, and really to start to understand this item after our visual review of the item, it would be appropriate to go to the supporting documentation. There are times when this doesn't work very well, and we're going to cover a section or something. It doesn't close the door in one or both directions, and we will discuss how to reactivate the unit as well. I did have a customer call about a month ago with a problem on one of these, and reactivating the pivot in the supporting documentation was necessary. So let's switch to the screen view and take a look at the supporting documentation. Okay, so here's the item that we're looking at. 7122 and a 600. And by the way, the 600 is the finish. And let's take a look and see what other finishes are available from Bommer on this steel unit. So 601 is, pardon me, 600 is prime coat. 601 is bright black japanned. 603 is zinc. 632 is polished brass. 633 is satin brass. 638 is satin brass blackened. Think antique brass. 639, that's going to be satin bronze. 640 is oil rub bronze. 643, satin bronze blackened, like an antique bronze. 645, polished nickel. 646, satin nickel. 651 is polished chrome. 652 is satin chrome. Now, what you'll notice is 7122 in a 632, which is a polished brass finish. You'll notice this price, and when you're seeing this video, it's very unlikely that price will be that. But let's look at the same item from this manufacturer when it's a brass-based material, which I think was a 7422. But then we would change it to 605. Or 7322. Yeah. So $271 versus $216. So price difference. You're going to get a much nicer look on polished brass. That's to be sure. It's going to meet all of the same specifications in terms of it being double acting, 36 inch, 2.5 inch, 75 pounds, not less than 1 inch thick. But now we're dealing with something that's made of solid brass. Okay, so just for comparison's sake, those are the finishes that it is available in and how it compares to the solid brass version. So back to the item that we are working on. Replacement Bommer tension pin. This link is handy as I just want to clean up the rest of the extended description information. There's a tension pin that is installed in the unit when you receive it, and should you need that tension pin, it can be purchased separately here. This is the tension pin for this series of items. Okay. And it is indeed unlikely that you would ever remove that from the unit, but I suppose should it ever be removed, for any reason, you can purchase it separately. There is also a tension rod that is included as well. And by the time you're seeing this video, we'll have a link added to the tension rod, which allows you to obviously adjust the tension. And we're going to go over the installation instructions on how to do that as well. So we've got some supporting documents: template, instructions, product catalog. The product catalog is where we're drawing the information from to know what the material is made of and whether or not it's adjustable. So we're looking at the 7122. The important part is that it's steel base and adjustable spring tension. The 7022 is steel base, non-adjustable. Okay. You'll notice that they have variations on the format that we're looking at here. And you'll also notice that there is a surface version and a mortise version. And if you study the difference on how the body is laid out, okay, the surface version, the door will literally sit on top of here, whereas with the 7022, the mortise version, or our 7122, which is a mortise version, the door will sit down in this area, which we're going to go over. So you can have the door sit on top of the unit, or you can mortise the bottom of the door out. That would be another defining characteristic of what the different styles are. So 7012, 7022, they're both steel and non-adjustable. We've got surface and mortise. The 7014 is a variant in the sense that it's a clamp style. So you might have a door where you need to have a more robust connection between the pivoting hardware and the door itself, for whatever reason. You might have an exceptionally high volume or unusually heavy door, a door that's not heavy in the sense that it exceeds the weight, but you might have it in such a sense where it exceeds the even distribution of weight. I've recently done a project where they used the wrong hinge. They used Bommer 3029 8-inch hinges on a door that was only 40-inch tall, and they had 3 of them on there. And their logic was the door was 150 pounds. And I says, well, how is that possible? The door is only 40-inch tall. They said, well, there's a giant granite shelf on top of the door itself, which is where all the weight was. So addressing the ability to clamp it together is important. And with this box clamp door bracket style, we have to define, we have to know that the box clamp is going to fit doors that are 1 1/8 inch thick. Okay, so that's what's going to be important there. As we get to our 7122, we have the same difference, surface and mortise. Okay, 7122 is your surface mount, and the 7122, forgive me, I said that wrong. 7112, 7122. Let's take a look at how the template really changes between the two. 7112, 7112 in a 6, that's brass, so let's say 632. So a surface mount template, you'll see that the door is going to sit on top of the unit. Now if we take a look at our template for a 7122, that door comes all the way down here. Okay, 7122 and 7112. That's the difference, right from here to here. So the one that you're going to select, you're going to need to think about, okay, how do I want to install this? Do I want to notch out this giant portion of the door on the bottom? Okay. Why would you do so? Well, you're obviously going to be able to draw or bring that door down much closer to the floor, which would be to the tune of, the mortise dimension here, or I should say the body height, which is expressed as basically 1 and just heavy on 1 3/4, 12, 25, 30 seconds. 1 and 25, 30 seconds is what that number is going to be. So you'll be able to affect that change by the height of that, by the height of the body. So that may or may not be of importance to you, but nonetheless, there it is. The same scenario where we've moved into the adjustable tension. We're still dealing with steel. And then your box clamp as well. This is the area that we'll get to further in the video where we're going to reactivate the pivot spring tension. Okay. Brass, 7211, surface, 7212. Surface as well, but what you're going to notice between the two, obviously, is how they attach to your jamb. Okay, so you're going to be looking to use this sort of material if you have a partition or some sort of panel that you're attaching it to, and you have to specify that jamb thickness when ordering the 7211. Brass, double acting, non-adjustable, and watch your sizes here because they do change. 7312, 7322, brass surface, brass mortise, double acting, adjustable. So same as our root series, except that we are now looking at brass and then more clamp styles. Okay, smaller version of the unit, the 7411, as we saw the 7211, 30-inch, 35 pounds. A gravity pivot that's here. Bommer has an offering of double-acting pivots, gravity pivots like this, the 7500 series, hold open, non-hold open, etc. So this is the product catalog. We'll leave that open because we're going to come back and look at the way to reactivate the unit. I think what happens is people attempt to adjust the tension and haven't read the installation instructions. So let's definitely move on to the next document. Okay, so we've gone over the product catalog. Now let's look at the template. And the template is going to give us the overview of what we need to do to our door to make it compatible with the product that we're working on. The door is being shown with a radiused edge. And, you know, tackling the most impactful thing first, showing us with a radiused edge here. A 1 5/16 radius maximum edge of door for the clearance. So the clearance that they're really talking about is the distance between, you know, the top pivot bracket and the edge of the door. Okay, so that's necessary to radius the edge of the door so that you can have the door actually operate within the door. If that's a square edge door, it's not going to actually move very far open in either direction. So they're looking for a roundover bit that has a maximum radius of 1 5/16. Okay, so that can be an awfully large bit. So be mindful that you're going to need to round over that edge in order to make it compatible. They don't give us the distance that I can see between the edge of the door and the top jam bracket, but it's going to be about 1/8 of an inch is what that would be. But however, we can absolutely determine that. They're telling us 3/8 of an inch clearance. We can measure the thickness of the sidewall bracket, which I can do right now. And it does indeed appear to be 1/4 inch, or close to it. So my caliper tells me that the thickness of the sidewall bracket is indeed 0.255. So yes, you're going to have 1/8 of an inch in here. Okay, and you will need to radius that in order to achieve opening and closing the door. If you weren't going to radius that, you're going to need to cheat the entire door over and away by about 1/8 of an inch. And I don't see there being an epic problem doing that. You know, just be mindful that this dimension is going to increase to, you know, 1/2 of an inch for sure. So they're definitely looking for you to round over that bit. You know, a 3/4 inch radius. You know, if you have a router bit that's going to be more available to you rather than a bit that would be, you know, 2 5/8 diameter, that would be a large roundover bit. So be mindful of needing to accomplish that. Since we're at the top of the page, they're showing us the top pivot, which gets mortised in here. And you'll notice that this is a 7/16 radius, so 7/8 diameter. Okay, and how you go about accomplishing that, it's only, the plate thickness is very thin. I don't see where they're giving us the plate. Oh, there it is. 134 thousandths thick, so just heavy on 1/8 of an inch. You might take a Forstner bit that's 7/8 and drill 3 holes exactly where they need to be, and that might just work out splendidly for you. Just heavy on 1/8 of an inch thick. You'll need to bore into the door 1/2 of an inch, 5/8 total depth, to accommodate the spindle coming out of the top jam bracket. Your jam bracket dimensions are here. That's for informational purposes. You're not mortising that to anything. That's just going to go to the jamb. Now the bottom of the door, you're basically going to make this large notch. That's going to be 1 7/8 plus, you know, to the edge of the door, holding the unit on my desk. We are looking at 2 5/8 dimension. Yeah, that would be spot on. This 2 5/8 dimension here. Sorry, I said 1 7/8. 2 5/8 overall width, and then your height of 1 25/32. Okay, this is called the boss. You're going to drill that a 1-inch diameter hole right in the center of the thickness. 19/32 maybe overall depth, 0.593. It's awfully handy to have a caliper when you're converting some of this. So you'll drill that large notch or prep that large notch in the door. Your fastening is going to occur down here. And then you're going to be mechanically fastened at that point. Okay. So obviously making sure that you are plumb is crucial to this installation. And that's going to be a matter of making sure that you line up your plates in the edge of the door. Or pardon me, on the cased opening frame. Okay. Making sure that's all lined up. So I don't think there's really anything else to discuss in terms of the template. Let's take a look at the instructions and see what that tells us. There's really not much to do on this other than mechanically install it, and then very likely not even the need to adjust tension, but possibly there will be. Caution: do not remove the tension pin from adjustable type pivots prior to installation. I think that's where people get in trouble with these. It does happen where they get, you know, that pin gets removed and then tension is lost and they're not sure why it doesn't work. If the tension is pinned, if the tension pin is removed, this could cause failure of the pivot to close the door in one or both directions. Call Bommer for instructions to reactivate, and we'll get to that further in this video. Installation of the top jamb bracket is number 1. Locate the top jamb bracket at correct height and secure to jamb. The door prep, you're going to have to first prepare the radius on the door edge, and you'll do that because the door is going to be obviously available to you and not having any hardware attached to it. And I would generally just lay that door down on my workbench and I would clamp it, and I would run a dedicated router over it with a large roundover bit, and it works out just perfectly. The one thing to mention about radiusing a door edge that needs to be talked about. Let's discuss something here. When you take a door, okay, and you are going to radius the door edge, if this is a 5-ply or a 7-ply or a 9-ply door, that veneer is really made up of layers. Okay, you'll have wood style here. Okay, and what I'm driving at with the reference to the layers is that when you go and run your roundover bit over this, you're going to accentuate the width of those layers. So be mindful when you're looking at the door, you're going to see each and every different layer in the door. So if you're taking a maple door that is a architectural 5 or 7-ply door and you're going to round it over, you're going to accentuate the veneer, the cross-banding, the backer, and the cross-banding. So you're going to want to be sure that you understand that you're going to have some alternating lines of light, dark, probably going to be light, dark, and dark is probably what it'll be, or light, dark, and less dark. And that's not going to look really great when you are, if you're putting a clear finish on the door. So be mindful that your door construction needs to contend with that radius preparation that you're obligated to do on the door without going through some other gyrations to avoid radiusing the door. Mortise top pivot socket into the top edge of door. Okay, we talked about that with the Forstner bit. Do it however you like. For mortise type pivot cutout bottom of door, for the mortise style, which is what we're dealing with, the 7122. Now this picture, though, is showing us a surface style, so be mindful. This is a generic image, not our product. Kind of have to take this and stick it down here. Drill hole in bottom of door for the projecting boss. Secure pivot to door with center of spindle aligned with center of hole and top pivot socket. So all of this needs to be plumb, is what they're saying there. Okay. Step 3. Installation of bottom jam bracket. Attach bottom jam bracket to pivot on door. Attach nut on hand tight. So what they're saying is you're basically going to disassemble. Let's switch to the screen, the camera view. You're going to remove this nut and you're going to separate the bottom jam bracket. Okay, so installation of bottom jam bracket. Attach bottom jam bracket to the pivot on door. So you've already separated these parts because you need to have them separated to, or well, maybe you haven't, but at this point you'll separate this and then attach this unit to the jam, is what they're saying. So literally you're going to remove this, and it's just hand tight when it comes from the factory, so you'll be able to separate that with your wrench. Okay, is what is going to need to happen there. Let's switch back to the screen view. So attach bottom jam bracket to pivot on door. Attach nut on hand. Attach the nut hand tight. So when you are reassembling it at this point, you're only going to put the nut back on hand tight. Locate and mark correct position on jam for bottom jam bracket by placing door and opening with top pivot pin in the top pivot socket and top surface of door held tightly against the top jam bracket. What I'd like to do is back up and go over where we are in terms of installation. The top jam bracket is attached to the jam at this point. Okay, we've radiused the door. We have mortised the bottom of the door for our unit, and we have drilled the boss in the bottom of the door. We have separated the bottom jam bracket from the pivot assembly by removing the nut. Okay. The pivot we have attached to the door, and we've aligned the vertical center line of everything in the installation. So the hole that we've prepped in the top of the door is completely vertically is aligned. Now we're going to install the bottom jam bracket. Attach the bottom jam bracket to the pivot on the door. So we've separated it, and now we're going to attach the bottom jam bracket back to the pivot assembly and just tighten it by hand, nothing beyond that. Locate and mark correct position on jam for the bottom jam bracket by placing door and opening with top pivot pin in the top pivot socket and top surface of door held tightly against top jam bracket. Okay, so everything is attached. This is attached to the door. This is attached to the door. The bottom jam bracket is attached to the pivot. Put it in the opening. Make all of this, the door, tight to the top of the door. Then you're going to mark the jam for your bottom jam bracket. Okay. Take the door out of the opening. Remove the bottom jam bracket from your pivot. Then attach that to the jam based on the marks that you've just made. Step 4 is where you're going to get the door hanging in the frame, and to do so you're going to remove the top pivot pin from the top jam bracket using a screwdriver. Let's show you what that looks like. Now you're going to remove this, or there's a screw right there. That's going to allow that pin to come right out. Okay. You're going to get the door placed in the opening, Place door in bottom, inserting the spindle into the bottom bracket. So at this point, you're going to place door in opening, inserting spindle into the bottom bracket. The spindle is right here. Okay, that's the spindle. Replace top pivot pin. Now you're going to insert the top pivot pin back in and engage the top of the door. With door in the closed position, place the washer and nut on the spindle and tighten securely. Now there are splines. You know what? Let's get a wrench and take a look and see what that looks like. Just needed a wrench to get that slightly loose. Okay, there's your spindle and your splines. Okay. Now when you get this reattached, you'll notice the bottom prep and the bottom jam bracket. When you get that attached, you need to get that straight in the opening and straight to the bottom jam bracket, because the next step is to tighten with door in step 4, the second half of step 4. With door in the closed position, place washer and nut on the spindle and tighten securely. This will draw the spline on the spindle firmly into the bottom jam bracket. Failure to tighten nut securely will allow the spindle to turn in the bracket, resulting in failure of pivot to close the door correctly. So that needs to be completely aligned, because when you tighten that nut down, those splines are going to get driven into the bottom bracket. That's what's going to help make sure that it's in the proper location. If the entire unit is moving in the opening, then your door's not going to, it'll move to one direction. It just won't move to the other direction. Now moving to step 5, tension adjustment for adjustable models only. To change the closing power, insert the tension rod, which is included, into the tension collar. The tension collar is that round feature that has all these holes in it. Okay, insert the tension rod into the tension collar and turn counterclockwise as viewed from the bottom. So as viewed from the bottom, you're going to turn it counterclockwise. Okay, which will just be counterclockwise. So you're viewing it, if you were laying on the floor and looking up at it, you're going to turn it counterclockwise. All right. We're going to remove the tension pin from the opening. So what happens is you're going to insert the tension rod. You're going to turn it counterclockwise. You're going to pull that pin out, but don't release your tension on the tension rod. Okay? Because that will allow this to completely come into a position where you'll have to reactivate the pin. So don't release your tension. Reinsert the tension pin in the tension collar at the hole location desired to obtain the desired amount of tension. So if you needed to speed it up, you're going to turn it counterclockwise to increase that tension, and you're going to move that pin over one hole is what will happen. So you're going to take the tension out, you're going to move, you're going to turn it counterclockwise, increase tension, take your pin out, move the rod further, put it into the next hole. If you want to decrease, obviously the reverse of that. You'll let a little bit of tension release and put it into the next hole. And that's how you set the tension on this. So when it comes to you, it's already tension set. Any adjustments necessary, that's how you go about making those adjustments. Now, let's go back to the product catalog where we can study how to reactivate the tension on a 7100 series double acting pivot. Now the steps to reactivate the pivot, we'll just discuss those because I don't, this unit is going to a client and would prefer not to put brand new merchandise into a vise. But in that product catalog, and I'll make a follow-up video on how to do this with an actual component in my hand. But the bottom line is, if the pivot fails to close in one or both direction, you can reactivate the pivot, basically setting it back to factory original specs. Remove the tension pin from the unit. You're just going to remove that. And when you're viewing it from this end, with the mounting bracket toward you, turn the tension collar to the left counterclockwise. You're just going to basically take your tension rod, or maybe probably just by hand, and just turn the tension collar counterclockwise. You'll turn that tension collar until it comes to a stop. Hold the tension collar in this position while you take the threaded spindle and turn it clockwise. Okay. At this point, once you have the tension collar turned one way and the spindle turned the other way, you're going to set the unit into a vise over the 1/2 inch diameter smooth area right below the splines right here. You're going to need to get that into a vise so that it can't spin, because we're about to set tension on it. So the threaded spindle will go into the vise. So the spindle is horizontal and mounting bracket is still toward you. Okay. The way that they're showing it in the figure is that you're standing over the vise this way, and I've got my vise jaws here. Okay. Place the tension rod in tension collar hole near the plate stop, which is A. This is the plate stop. Okay. Place the tension rod in collar hole, so we'll place it here near the stop, and turn the collar toward you, which would be counterclockwise. So we're really looking at it from this perspective, and you're just going to turn it toward you, or what would be counterclockwise, until tension is felt. Insert the tension pin in the hole in the tension collar to the stop on the cover plate. Pin must be fully inserted into the hole with the shoulder of the pin against the tension collar. Allow the spring tension to rotate the collar and tension pin toward the stop until the pin contacts the stop. Reinstall on door. So let's go over that one more time. Place the tension rod in tension collar hole near the plate stop and turn the collar towards you until tension is felt. Then you'll insert your tension pin into the hole in the tension collar that's close to that stop. This is the stop. Okay. The pin must be fully seated in the hole, and you're going to make sure that you install it so that it looks like that. Actually, you can very easily just take it out. Okay. That's what our tension pin looks like. And obviously I'm holding tension on the tension collar. Okay. So you'll insert the pin. It has to be fully inserted to allow the spring tension to rotate the collar and tension pin towards the stop until it contacts the stop. So you're going to set, now at this point, you've got tension set on the spring, and then you can go back to adjusting your tension. So basically it's turn this counterclockwise, turn this clockwise, put it in a vise, rotate the tension collar counterclockwise, and set the pin in place. Then you're back to factory specs, is how that is. And that brings us to conclusion of this item. Steel-based and adjustable, very common. We do sell, I think we sell more of the brass, quite frankly. And I think it's because we're seeing high-end millwork applications that are using these. Courtrooms. The last time we sold these, the project I had mentioned just earlier, that was a high-end casino where they had the need for a double-acting door. And while we didn't use a 7112, we used its, so back to that, the 40-inch door, 3 Bommer 3029s on it in an 8-inch size. That's a huge hinge, okay? And the guy says, yeah, the door is, when it double acts, it's hitting the jamb. And I says, well, you've got enough spring power there to hang a 150-pound door. He's like, yeah, that's what the door weighs. I'm like, well, what's the problem? He's telling me that it's 40-inch tall. And then he says the granite countertop, so all of the weight of this door, the majority of the weight, is unevenly distributed. And so what we came up with was removing the 3029 double acting hinges, going with a 7800 series floor pivot, so all the weight is borne on the floor, and then we used the top jam bracket from a 7100 series. We had to align the vertical axis of pivoting because the templating for a 7100 series, this item, and a 7800, that's got a different vertical axis of pivoting center line from the jam. So I think they needed to pad this out 1/8 of an inch. The 7800 allowed the floor to carry the weight. The top bracket from the 7100 series allowed us to absolutely capture the door so that it couldn't move out of the opening and then go elliptically, okay, because of that uneven distribution of weight. And it worked flawlessly. You had a good carpenter, is what the client had, who could understand the concept of what I put together, and it worked perfectly. Client super happy. That 7800, we went with a 7813 or a 7814, a heavy duty that will handle the weight of the door. And again, flawlessly it worked. Now, let's finish up this video with a, if you'll look back at the product that we're discussing, there is a link on that page to the manufacturer's page within our site. And from that page, you'll be able to view not only all of the Bommer products that we sell, but a link to the manufacturer's website, as well as a link to the full product catalog. I would recommend a view through the full product catalog because Bommer is a company that was started about 1877 by two brothers. These gentlemen invented the spring hinge. The evolution of Bommer over the almost 150 years has been the continual refinement of the spring hinge space. Their current catalog is not only what they manufacture currently, but what material, the material that's available today is directly derived from material that's 100+ years old in design, plus, no doubt. And the name Bommer is synonymous with single acting, but probably more so double acting spring hardware. I am quite partial to Bommer, and it is because their logo is not on here. But 100% of what Bommer does is manufactured in the United States. The raw materials are all sourced domestically. I have been to their facility, both of their facilities. They have a plating plant, and then maybe, I don't know, 15 miles away, the hinge manufacturing plant. The plating plant is a point of deep pride for Bommer. The residual material that they eject into the environment, water, is cleaner than the local municipality's drinking water. So they're very proud of their plating operation. Bommer can do 33 finishes. Very proud of that as well. The owner of Bommer is married to the granddaughter of one of the two original founders. Another contention of deep pride for the company, naturally. And as ownership at Bommer would say, they'll stack their quality, their shipping lead times, and their customer service up against any other manufacturer. And there's just no doubt that that's a true statement. No doubt at all. And I hope that Bommer is around for another 150 years. Any questions on the 7112 and a 7122? This is the mortise style, not the surface style. 7122 and a 600 finish, or any other Bommer product, please feel free to reach out to us. And thank you.